take it away, Jim.
So I'm sort of disappointed they fixed the projector because, you know, science had a dance your dissertation competition. I was thinking I could, you know, interpretive dance for the semantic web, but I think we're all lucky that I don't have to do that. So knowing that I was talking after Laszlo, I figured it was probably a low risk to say that my talk would probably be a little different than his, and I'm happy to say it's probably a little different than his. And I also am going to try to bring some stuff in, sort of in background to the talk, because I was sort of assuming one of the earlier talks today would really do a little bit more of what did we mean by web science. So, you know, web science came from an article, you know, the term started to become popularized with an article that some of us had in Science magazine called Creating a Science of the World Wide Web. And we really weren't arguing for network science. We were arguing for the creation of a science about the World Wide Web. The web is a real thing. It's not an arbitrary network. It's not a random collection of, you know, atoms in the universe. It's a specific set of machines doing certain protocols, things like that. So it seems like from a scientific and analytic point of view, a lot of the network science was related. From an engineering point of view, it's clear that the web is something we build, we create, and also that we can experiment with. We should be able to try, in a sense, how would we instrument the web? The thing is growing so fast, a lot of people are still testing their techniques on the graph that Laszlo showed us from 1999. The web is nothing like it was in 1999, right, as far as we know in terms of capability, in terms of what people are doing with it. It may be mathematically similar. We don't even know that now because we're not even sure we're sampling the right thing. A lot of things on the web, for example, in the early web graph, that was mostly the HTTP graph, which meant that Facebook, if you did it that technique, would show up as a node, not as 500 million links, right? So again, so what's happening in the back end of Google? Google gets millions of hits a minute that it's never seen before. What pattern do those look like? When it's doing its map reduces, is it seeing the same sort of network structures and scale frees, et cetera? You know, I mentioned to Laszlo outside that I wasn't going to critique his talk from the point of the science. I can't critique. He's better at that than I am. But we're studying a 10-year-old algorithm that even Google doesn't use anymore, right? They use it a tiny bit in a couple of things, but that's not how search works anymore. We still teach that to our students. But you go to Google, the first thing they tell you is, forget about PageRank, right? You go to Bing. Bing's not allowed to use PageRank, right? That PageRank is a patent belonging to Google. So studying what's really going on, being predictive, looking ahead, strikes me needs a combination of that science, that engineering, and of course, the social aspect. So the talk I was really hoping Laszlo would give today was the one he gave at the Royal Society a few months back, where he talked about sort of how the web was like many other scale-free networks and how it was like the formation of galaxies and the signaling network in your body, which is true from a certain point of view, but from a different point of view, that's got to be, in my mind, what's least interesting about the World Wide Web. Because if it's just the parts of it that are like all the other networks aren't therefore going to tell us why it's changed the world. How is it that you've got a father in Egypt naming his kid Facebook because it was so influential in overthrowing a dictator? I mean, you know, the world is changing in a social way. The notion of property, right? The law courts are full of suits over what's going on in the record industry. That clearly, if we're just studying the link topology, we're missing something really important. Now, they're clearly related, and that's what, to me, is the most exciting thing about web science, is that we can take that network, that engineering and instrumentation, that ability to actually manipulate the thing, and the social effects, and we can start to come up with something that will be a social computation, social science can look at a computational engineering background they've never had before. Computer scientists have real people doing real things that affect our algorithms. Right? Don't forget, the base of that PageRank algorithm is the web graph, which was links created by people. It wasn't links created by the ER algorithm throwing a whole lot of dice. And so the fact that it had those stable properties for PageRank is interesting, but again, why? If every network has that, that's interesting, but why would a bunch of people linking their pages together end up in a certain way? We've tried preferential attachment, we've looked at a lot of network growth things, but somehow we seem to never quite capture what the web is about. The other thing is, the web is really important, right? We can't sort of ignore this thing. So I like to say that the really crucial thing to me about web science is the web, right? Is the thing we're studying. There is a thing there, right? So since I don't have slides on this and I'm talking off the top, I'm doing the interpretive dance now. I'll get back to the point I wanted to make, but I just wanted to bring that up because that was the backdrop I want to present my talk against. So what I want to look at is what's happening in the semantic web. Tim mentioned that earlier today, some what's going on at the language level. And I'm going to try to sort of throw some of this out as a challenge to some of you network guys, which is we have this real network evolving. It has some interesting properties and is starting to scale and things, and we need to figure out how to make it better. So there's a famous book called How to Be a Jewish Mother, which includes a chapter called How to Ruin a Joke. And it says, start with the punchline and then work your way backwards. So I'm going to do that with my talk. So my conclusion slide is the semantic web is real. It's growing at a very fast pace now. It's producing lots of very interesting networks that no one is really analyzing from a network science perspective. And it would really help those of us trying to use this stuff to actually understand it better in a mathematical sense. Very much as the first talk said, it would be nice to have some good theory at the bottom of the stuff we're building, because this stuff we're building actually is affecting real people, like it's a big part of the open government movement, and I'll go through a little bit of that today, like it's really affecting how things are working on the web, like it's really changing our lives. We really need to know what's going on. So the first thing I want to do is sort of my semantic web is real piece. I've been giving talks about the semantic web since about '99. Sort of the term became much more popular around 2001. And I always had a slide, it said, this is what companies were doing, this is what, and it usually was a sort of trust me, stuff's happening, we'll get to it. What's really nice is in the past year, I got to throw out that slide because now I just use real news reports, real things people are doing. So Facebook started using some semantic web technology, announced back in April. I'll show you more about that a little later. Best Buy has been using it. Well, Best Buy motivated Google to start accepting some things. So again, I'm not going to get into a lot of the details, but this is the normal search result. This is the enhanced search result when certain semantic stuff has been embedded in a certain language using some of the kind of terminologies Tim alluded to today. So this is really exciting to companies because guess which one of those two is more attractive to your eye and it's going to get more clicks if you show it as search results. So since right now search engine optimization owns the web, anything that helps you do better in search engines has a big commercial impact. So that got a lot of excitement. In fact, it got so much excitement that Google actually bought a company that was involved in some of this stuff. So Google bought a company called MetaWeb, which does a lot of RDF-based database stuff. There's a rumor that they're putting that stuff together. Google, Facebook, and Twitter build the semantic web. All of these companies are starting to do this stuff. And again, notice the dates I'm showing you. They're August 2010. One of them was November 2010. So what's changed? What's happened over this year has really been two big things. One has been semantics and search, as I mentioned. One has been that essentially since advertising is driving the commercial side of the web, what's been a problem for everybody but Google is that there's no middleman when you do a lot of the web stuff, or there wasn't before. And over the past couple years, that's evolved. So the idea is that when you see the advertisements on the side of your page and you click on one, different people are sharing money. I had a 2-hour lecture someone gave me on that recently, just so I could know the basics enough to be able to talk about it intelligently. And I still really don't get a lot of the details of how click-throughs and ad placements. But the key is now you can make money on the web by being a middle company. What you do is you help people who produce information find people who want to consume it, or real things. So again, eBay, Craigslist were sites you went to. Now the question is, can you take that stuff out? So there was a big market evolving around that stuff, and the more precise the information is, the better off you are. I'll talk about that a little more in a minute. And then the other thing is, between Facebook starting to really use the semantic web technology, a lot of stuff happening in the open government movement. So, probably a lot of you are unaware that the US government now gives away over 300,000 data sets of government data that you can go put your hands on and play with. The British government has about 5,000. British government is ahead in terms of actually defining URIs and naming schemes and solving some of the issues of who's allowed to touch what data. So government data has become a huge and influential area where, again, semantic web showed tremendous amount of potential. And then the other thing going on was the maturation of the early, those of you who remember the old semantic web stack, the bottom is now really getting robust. You can scale it. You can use it on the real web. Anyone wants to hear details, argue with me, et cetera, I'll take it later. A lot of you have probably heard a friend of a friend for the past 5, 6 years. It's the only thing those of us who had a lot of semantic web stuff got to talk about. There are a lot of people in this social network. It was analyzed as a social network. Lots and lots of the big web applications touched it. You could take the information from FOF and build the same kind of nice big web things you did. So the top pictures there are if you actually take the picture who you can locate through, take all the people you can locate through the FOF network, and then find everyone who knows each other, and then draw those on a real map. That's what it looks like. There's some interesting phenomena there when you look at it at scale. My favorite is how many people seem to live in the middle of the ocean. What we think is going on there is several things have the lat longs are actually long lats, and there's actually no way to tell because the numbers are exactly the same. They're both numbers from 0 to whatever, 180 or 90, whichever it is. So when you see somebody living in the middle of the ocean, you're pretty sure that's wrong. But when you see somebody living, somewhere in the middle of the map, you have no idea whether that's right or wrong. So again, we're trying to figure out how you could even analyze that stuff. This is a tree map of the 50 million most used terms in this stuff. I mean, again, we can do all the social network stuff. It's boring. Here's what starts getting interesting. I don't mean it's boring to do social network stuff. I bet FOF is not very exciting as a social network. When you can get your hands on Facebook with 500 million people and much more organized information, things get less interesting. Facebook started using this stuff for something called the Open Graph Protocol. So when you want to put a like button on your page, there are different ways to do it. The way Facebook is now promoting the most is you embed some XML with the RDF built in. So you sort of say, so this says, this is the site name, and here's a description in human readable forms. These 7 terms, so that's the entire ontology. Very simple. There's also some standard fillers. There's about 40 of them. So the whole thing is absolutely tiny, right? What's interesting about it is it's already in the past few months gone up to 15,000 of the top 1,000,000 sites, which is very good growth. More interestingly, Facebook reports that about 10 to 15% of the like buttons are now using this. The like buttons generate 3 million likes a day. So that means we're probably getting in this RDF stuff about 300,000 a day. Okay? And what those things are is just simple relations. This guy likes this thing. But what's interesting about it is sometimes you like people, sometimes you like things, sometimes you like movies. So you're getting essentially what's the equivalent of a labeled graph at very, very large size. Now, at the moment, only Facebook is getting this. You can actually harness this stuff. You can go to the same pages. You can have like buttons on your page. Look at it. Facebook is talking about releasing some of the like information. So this little bit of RDF has grown much more interesting networks very quickly. So that's just to give you an idea that when I say this stuff is real, I mean, it's not now at the scales of a few universities or farting around with it. The high-end expressive AI stuff has not yet found a market at these kind of scales. This very simple language stuff. So roughly think of it as, instead of unlabeled graphs, which are mostly no relations, you're now talking about multiply labeled graphs that are getting to very large sizes. I'll show you what I think is an even more interesting one. So here is the use case of government data sharing. This is just US and UK. There's actually a lot of other countries involved in this. You can start this line at various places. Most people are starting it these days with, when Obama was elected, he created something called the Open Government Directive, which said government agencies will share their data as a step towards transparency. And he had some other transparency things in there too. May of '09, a site was released with 57 data sets. Meanwhile, in the UK, Tim and Nigel, who's not here yet, started convincing Gordon Brown that the UK should be doing this too and should be doing it better. There was a nice arms race between the two for a while, between who would release more data sets. The US, being a lot bigger, decided it was going to win that race. So in May of 2010, it released 300,000 data sets. Very, very mixed quality, very odd stuff. A lot of it's edge sets, how it relates to each other. I mean, we're still even trying to understand what's in there within the government team, let alone as citizens. But there's a bunch of it that's been well categorized. And by the way, that's roughly the same size as now the British. So both of these places have 6,000 or 7,000 data sets. And these aren't tiny little data. I'm not talking, 6 elements. Some of these things are like the US Census, right? One of the ones the Brits are releasing now is every single street crime in Britain with its exact location, time of date, et cetera, over a very long time. So notice, I'm hoping some of you who are network scientists are already starting to wonder about whether some of these data sets might be great things for analysis. The crime network for Britain, it's got to be interesting. Okay? But more interesting to me is the whole set of this stuff, what's going on in there. So a lot of what we've been doing, I use we now to mean two different things. Me and my role as a researcher, because I actually do this in my lab. And as of last May, I was actually asked to come join the Obama folks. It's actually run out of the GSA, for those of you who care about your US agency. So it's the entire executive branch. Data stuff to help advise them. And the reason I was asked to do this is my students and I had started playing with this data and had built approximately 50 of these little data mashups. We just took lots of different kind of visualizers, lots of kind of data sets, and started putting them together. And that attracted the government's interest because previously sort of getting one good government sort of data application was something that they were giving contractors lots and lots of money to do. And they noticed we had done 40 or 50 of them for free using mostly undergraduates in a very short period of time. And so they wanted to know what was going on. And we said, well, the semantic web stuff was designed for this problem. So it's not surprising it's a very good technology to use. And so we've been able to use it. So there's lots of details in here I won't go into. Let me just give you one example. So here's presentation one of my students did. We were at a conference in China. We learned that China gives away a lot of their data too, though only economic data. So here's the gross domestic product of the Chinese in billions of yuan. And there's the GDP of the US in billions of dollars for the same year. Obviously, a one-to-one comparison between those two isn't very interesting unless you also know the exchange rate for the yuan versus the dollar, which we actually were able to get from one of the data sets on DataGov. You also probably want to play with the population, so you can either divide that by the population or not. Populations of all the countries on Earth are easily found on the web. So what we did is we grabbed the Chinese yuan data, the US data, the data about how you convert one to the other over the different years. So we had those I think by week. The population data, and then you can see how those are growing compared to each other with respect to various things. And you can, in the actual demo, you can click different buttons. Here's what I think is the most interesting thing. This thing took about 8 hours by one postdoc and one student. We discovered on Tuesday afternoon that the data set existed, and by Wednesday we were demoing as part of our demonstration of our system. Again, not because we're magicians, and not because we had 50 people pull overnights, but because this stuff is tailored to do this kind of thing. Okay, so we were able to mash up a bunch of different kind of data sets because we had good technology for bringing it together, merging it, playing with very lightweight metadata, a little bit of inferencing, that kind of thing. One of the things that's really interesting about this from the government perspective is that these mashups can reveal things that the individual data sets don't. I felt compelled to show this one because Nashir and one of my colleagues are doing it jointly, so it proves we actually do talk to Northwestern. But this is a bunch of smoking data. What we were able to do was not only replicate stuff that NIH had spent a very long time collecting from, we were able to validate it against some external sources, but we're also able to show that we can bring in many more factors, compare them to each other, things like that. So I won't go into the analytic part of it, but you can take what's fed into any of these things, take it out into either Excel or to a stat pack, and then run it so if you want to prove a regression or something. So you can essentially play with your curves until you get them to start showing what you think. Hey, this one looks interesting. And then what you can do is dump them into an analysis package and things to say, are they really interesting? It doesn't solve any of the known data analysis problems. How do you know what's a data error? How do you do that? I have a whole talk on that I won't go into today. A lot of work has also been taking government data and mashing it up with various kinds of social media. So this is, so the green the depth of the green in this, I believe, you can't really see it very well on this projector. You can see it better on my screen, but there's sort of very light green to very dark green there. That's how much internet use there is per state. And then the dots are tweets, I forget, I think it's thousands of tweets each about Haiti during the Haitian thing. So you can see where were people tweeting and how did that compare to different things. Again, we could change that background to compare to how many libraries are in the state, how many, what's the temperature of the state. So again, things that might be meaningful and things that might or might not be meaningful. The comparisons become very easy to look at, to run, to explore. There's also a lot of workflow information. So from the point of view of sort of why the network is actually getting complicated, is not only you're getting, sort of some kind of triangular data, tabular data. You're not anymore. Now you've got a graph, and in that graph, you're also not only keeping track of the data, but where it came from, who produced it, how it's derived. Because you need that so that if later somebody said, well, where is this number where you're saying China doesn't have enough GDP here come from, you can sort of click on it and you'll actually see the whole provenance trace, things like that. Here's why we would really like some good network science and some other kind of analytics back here. Is just one of many examples. So you're searching for some data. So let's say I would like to find what data is out there about Alaska. So in data.gov, I have a keyword search engine. If I type Alaska, it will show me all the data sets that in its metadata description have the word Alaska. You don't want to search within the database because chances are within the database, the string Alaska isn't going to show up. And if it does, it may or may not actually be in a field that has anything to do with Alaska. Alaska could be Alaska, could be AK, could be state 2, could be S27:13B. The data dictionary for most of these data sets is about 140 to 150 pages of machine readable, of human readable PDFs. So, if you want to sort of search in those documents, it doesn't, saying, yes, these are the documents that mention Alaska won't be very helpful either. And what's even more interesting is just using your human knowledge isn't always so great either. So in this case, I won't go through how the whole demo works, but we have a bunch of data sets, 20 or 30 of them that we grab. And the question here is which of these data sets are about Alaska? Every one of these data sets is about every state. Each of these data sets say, this covers the US states. Almost none of the data sets actually have all 50 states in them. So for example, well, you can't see it there, but like Massachusetts is mentioned in 4 of the data sets. Alaska is mentioned in 22 of the data sets. Okay. More interestingly, that's American Samoa. For those of you who aren't America, American Samoa is not a state. It's a, I forget, Commonwealth Protector or what, Guam, American Samoa, the District of Columbia, and Puerto Rico show up in a lot of these data sets. They're not technically states. So again, it's easy when I tell you one of these examples and one of these sorts of things to say that doesn't sound so hard. Remember, we're looking for this in 300,000 data sets. We have no schema information for most of the data sets, only some very weak metadata. We're looking at learning techniques. We're looking at figuring out what predicates tend to identify things. If you see a bunch of things in a column that you're pretty sure are states, and there don't seem to be more than 50 or 60 of them, maybe they really are states. You can think of a lot of heuristics. We'd like to do better than that. So how do you build a data search engine when you can actually put your hands on the data, you can actually learn some things about how the data links to other data sets, that's actually recorded in there, I'll talk about that in a minute, and you can actually sort of really analyze this stuff, but there's stacks of it, right? So, you know, if you go to scientific database guys, they're talking about terabyte databases and beyond, petabyte now and beyond. But they're generally one or a small number of things with a clean model. Here I've got 300,000 things with few, if any, models. And most of them you can't even, the model, if it exists, you can't have. There's government reasons why the contractors who build the systems own the schemas. The government owns the data. So we have a real problem here. And the problem looks like a network. In fact, this is something called the Open Link Data Cloud. I'll just point at this part of it as the government part. So there's also stuff in here. This is life sciences. This is publications, music. This thing has been growing fairly rapidly. The estimate, what was it, Tim, about every 10 months it's been doubling for the past couple, 3 years? Yeah, so for the past 3-4 years it's been doubling in size roughly every 10 months. So government data is about, it doesn't show up here because of the way the layout is done, but government data is currently about half the cloud, great deal of that being US and UK data. It's about 15, so if you just take that data and nothing else and build it as a graph, that graph has 15 million links in it, all labeled, so it's the subject, object, predicate stuff Tim was talking about. The links, so when this shows that this thing has a link to that, that's not one link, that means somebody has done some kind of mapping between those. So there's tens of thousands of those links. Now notice that's a small number compared to the amount of data. The linked open data cloud is more than 23 billion triples at the moment. It's a sparsely connected graph of highly connected graphs. And we know very little about the properties of most of these graphs and about the whole thing. So here's a nice challenge, you know, to those of you who like to do graph analysis, right? There's some really interesting data here. It's really important. It's really challenging to us. We really need to know it. I wish I had another slide here I meant to put in, I forgot. So, a company called Socrata actually did a study. They went out with a survey. They surveyed, I think, 1,500 random people. And they were asking them, have you ever actually looked at government data on the web? Expecting that what they were going to come up with was something that said, almost nobody has looked at it. And what they discovered is 30 to 40% of the people they queried said yes. And a large number said, I do it on a regular basis, because they would go look at things that newspapers publish, things that bloggers pointed at. So a lot of people, when they're searching on the web, are finding things with data in them. A lot of that relates to government data. Whether it came from this data set or not is another story. They didn't have any way to tell that. But and now we look at this bigger thing, and you can imagine we've got people who've linked. So at the center of this thing is this thing called DBpedia. DBpedia is the semantic structure of Wikipedia. So when you have a box in Wikipedia, so this Wikipedia page has this little box that says, here's this person. So if we went to Einstein, for Laszlo's example, right, it says he was born in a particular place, he won certain awards, his parents had this name, his kids had this name. If you go to Tim's page, he has a box and it has some of that stuff. You go to my page, and most of the people in this room's page, a lot of you probably have those boxes. So it started just with the information in the box, because that's pretty easy. If this page is about Einstein, it says he was born in a place called Bonn, then it's pretty easy to go Einstein, born in Bonn, right? In fact, DBpedia was read in by Watson, the Jeopardy playing program that beat the world's experts a couple weeks ago, and it was used in creating its type hierarchy. If you've read the final Jeopardy book, or if you listen to any of the presentations about it. You know, they had these things called LATs. I don't remember what it's, but essentially categories. And that the categories were determined, they needed to know, so if somebody was a person, they weren't a place, right? So you needed to know both what kind of category is the question asking. So as he is, it's probably talking about a person. Things like that. So a lot of the heuristic, very little heuristic knowledge, very little organized structure in Watson. It was mostly mathematical relations, statistics, language tricks, things like that. But the one thing that they really used structure was that DBpedia. Now notice DBpedia is sort of the center of this cloud, and that's sort of historical. It came early on. It had a lot of very attractive data. So a lot of this stuff links back to it. By the way, they've now extended it, so it's not just the stuff in the boxes. It's basically the entire link structure. And as of a couple years ago, DBpedia made it an official part. Oh, sorry, Wikipedia made it an official part of the Wikipedia project. So now they actually help support and work with this. So there's so some of the policies with respect to how you share data in Wikipedia, how you author, things that include what's the expected stuff at the semantic end. So again, another place where there's some very rich semantics happening. So again, this cloud, right, has millions of links throughout it. I'm sorry, billions of links throughout it. Thousands to millions of links between things, and you know, a structure we know very little about. But I mean, this is not an epiphenomenal thing. This is not some random thing that happened, and we can, you know, are curious what its network structure. We need this stuff. Does the government stuff? A lot of web companies want to do it. Things like that. So the really nice thing for those of you who like to play with networks is that entire thing is web accessible, machine readable. Most of it's anonymized against any. So there's the and is because I couldn't remember the final conclusion, which it's very lightly licensed. What I can't remember is if it's CC0 license or one of the similar things. But basically, if you play with this data, you don't have to go get an IP agreement from some game company that says you're allowed to touch it only if you lock the doors of your room and don't ever show it to any of your postdocs. This is really open, shareable. The bad news about it, as I mentioned, it's doubling in size very quickly. There's very varied authority. Some of this stuff's out of date very quickly. Some of this stuff is being generated by large companies that maintain it rigorously. The government data, particularly the UK government data, is being released directly by their ministries. Many different kinds of linking are used, so you can't just sort of say, well, we'll just take the labels on this thing and build it into a label graph, because you have to worry about all these different things. So some of them are, the main linking is just two things actually refer to exactly the same URI, but there's also things where someone says this is the same as this. The problem is they're using something that mathematically is supposed to be exactly equal, but can't possibly be exactly. So if I say what this guy calls Berlin is the same thing as what this guy calls Berlin, that's the same entity, but in fact, this one's described here and this one's described there, so you already have things you have to take into account. So there's a lot of other vocabulary starting to float around for different kinds of assertions of same as. There's a sort of the same inference, so there's ways you can say, so two people with the same social security number would be the same person in the US system if it's correct. There's ways to have those kind of assertions in here, so you can say, if I'm looking for someone who's named here and someone who's named here, and I have this rule, then that rule will give you literally thousands of links. There's transitive closures throughout this thing, so for a lot of these, like a knows relation, you have, if A knows B and B knows C, you can't conclude A knows C. For a lot of these, if A is the same as B and B is the same as C and C is the same as D, A is the same as D by some definition of same. It also has, for those of you who'd like another reason to play with this stuff, so what I tell you is there's a lot of cool stuff there. It's easy to get your hands on. We don't know much about it. It's a largely unstudied space, and it's an important web space. But also, it's becoming important for another reason. The term Web 3.0 has started to be floated around. I won't go into what I think it is and why it's about, but what pretty much everyone agrees, it's some combination of Web 2.0 plus the semantic stuff. So it's not just what Facebook does, and it's not just OGP. It's when you put that stuff together. And here's what's interesting about that, why it's generated a lot of interest. So if we look at the web and look at Google, Laszlo's was a great talk to lead into this. So what was the underlying thing behind getting Google to work? It was the hit algorithm and later PageRank. It was sort of the underlying theory of hubs and authorities in that web graph, right? As you went to Facebook and the growth of Facebook and other social networking sites, the math of the social network has been exceedingly important in sort of figuring out how to scale that, what you could recognize, how you could do things. So here's a space where a lot of people think the next big breakthrough company is going to be. We're pretty sure it has to do something with these big graphs plus semantics, and no one knows what that company is going to do yet. I know a lot of companies that are trying to be the one who does it. So if you're the kind of guy who likes to do your graph theory and then try to make a lot of money out of it, here's another place to play. So again, I hope I've convinced you that the semantic web is real. It's growing at a very fast pace. It's producing lots of very interesting networks. The networks are largely unanalyzed. We really don't even know what tools to use on a lot of this stuff for those of us who do the sort of government data side and the more semantic side of it. A lot of my students will take that and throw it through tools you guys have built, but we're not really finding the right stuff we need yet. So we really could use some help from this part of the web being looked at as this new emerging kind of network in a way that would really help us solve some very hard problems. So I'll stop there. Thanks. And since Nash said we were supposed to hype our books, and I forgot to bring one, I'll hype it. The second edition of our book is coming out, and it actually has added OGP, the government data stuff, and a bunch of other stuff, Sparkle, SCOS. I guess questions?
I don't know if is this on? I was just curious, sort of going off from some of the points you raised at the beginning of your talk and just then about how, can web science keeping up with, and network science keeping up with the realities? You mentioned how Google PageRank might be changing and all these things. I also wondered, I didn't hear you mention, but is the mobile web going to affect the ability to research these things too? And this is more of a question maybe for other people in the room too later. Yeah. Is because I know like the Chronicle just came out with an iPad app, just like everyone else, I guess. And articles, when people download that whole batch of articles, I don't think we have the same kind of data on whether, or I don't know if you guys could do as researchers links of like who clicked on our articles there versus on the web, and it just seems to be fragmenting again from being a centralized network. So what does that do to just as you guys figured out how to make all these amazing, interesting observations, is it, can you keep up?
So it's a brilliant question. A couple people laughed when I put up my title slide to notice I was called the tetherless world professor, but in fact, what a lot of that was about was it was originally going to be mostly about mobile networks. Someone else at RPI ended up becoming famous in mobile networks, so I didn't have to. So I got hired to actually look at web phenomena. One of the ones we've been looking a lot at is that whole issue. There are about 5 billion of these in the world, not necessarily smartphones, but web-enabled phones. There are about 1 billion of these. These are about 80% owned by companies with, I forget the percentage, but it's like 60 to 70% of that owned by 5 companies. Okay? These are primarily owned by individuals. Okay, so you're talking about a very different web out there. You also, I'm sure you all know there's this big issue going on between sort of the app world and the web world, which you alluded to. One of the things some of us believe is that what's really going to be the winner in the long run is those apps located on a web infrastructure. So right now, if you have your Facebook app, you've got, or even on the web, you have a bunch of groups that are Facebook groups. And then you have your Twitter groups. And then you have your LinkedIn groups. And then you have your email. Why isn't group an idea that could live outside of the apps and all the apps could let you maintain your groups? There's a thing out there called Web ID. Those of you who don't know about it but are interested in web stuff should go look at it. So, why don't you have the equivalent of an email address on the web? Right? So I can have multiple email addresses. It doesn't uniquely identify me, but I should have, but when you get email from that email address, you know it's from me, assuming the mail system is working correctly, which may or may not be the case. So on the web, you should have a way that says, this is this person. If you want to find them in Facebook, it's this. And if you want to find them in Twitter, it's this. And whatever I've chosen to reveal. So Web ID is, I think, going to be the first of these sort of pervasive APIs built on top of the REST API that will live for the mobile web, and then a lot of it connect up. Now notice, then the question becomes, what does that network look like? Do you have a network imposed on a network? A lot of what we think is really interesting on the web is that this stuff is changing very fast, that the web doesn't look that much like the old web graph. Now, we don't know whether mathematically it still looks like the old web graph, and I think that's a really exciting and interesting question to be explored. And then, sort of the rest of it I'll take offline with you because I can talk for hours. Any of this stuff, but especially mobile. Yeah.
Any other questions? Jim, I have a question.
Yeah.
Talking about the possibilities of this data for people who do network analysis. What advice would you have for the very basic questions of how do you start to define different types of links and the meaning of links and all the very basic questions of what does a connection mean in all of this data when there's so much heterogeneity? Lada's talk, for instance, really brought out some very big differences between just trust and friendship. And unless you can get at those issues, it's really hard to apply some of the network tools.
So I turn that question on its head a little bit, right? The real starting point is figuring out the right questions to ask, I think. And so so I now work very closely with a bunch of people who do open government research. So the kind of question they want to ask is something like, does releasing this data improve government transparency? And the question becomes, and it gets back to that very first talk, what kind of theory could inform that kind of question, right? What kind of things can I look at to determine whether it really is the case that citizens are better able to do things they want? Well, when you start turning into I love it. My next talk. So I think that a lot of these data sets, the data sets themselves are very straightforward and start to be a good place to look at some of that analysis. But then when you start to say, how do I verify that? How do I compute that? You start saying, well, I have to put these data sets together. And starting to have a vocabulary of what that means and things like that's important. Now, the linked data cloud is a great starting place on that because we've been working on it for a decade. Mm-hmm. And so we have some of those vocabularies. We have some good links. The OGP stuff is a nice place if you want to look at web finance, what kind of names are in there, things like that. So some of it is we really need to start having a lot more workshops like this where people start learning each other's vocabulary and we start realizing that there's a lot of common stuff out there to use, and then we can start saying, well, in this kind of thing, it looks like this, and here's how you look at it. And that's my real message to you all today. Is, there really is a multidisciplinary, interdisciplinary thing that's forming around the way different people study the web. The analogy I like to use is like climate modeling, right? Climate modeling doesn't live in the oceanography department or the astronomics department or something else. It lives in combined panels and combined papers and new meanings. And I think that this web science stuff is very much like that. I don't expect to see a web science department when I walk on a campus. What I expect is of people in information schools, people in information departments, people in networking departments, many of them who are interested in the web working together to try to answer exactly the question you just asked. So, thanks.
Yes, thank you.